Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating blog post, Hard Mode Rust, a deep dive into building a ray tracer with severely limited APIs. Get ready for some serious technical discussion.
I'm pumped. This sounds intense. The core idea is to restrict the Rust code to avoid dynamic memory allocation, right? Like a hardcore C programmer's challenge to Rust and C++?
Exactly. The author critiques RAII, resource acquisition, is initialization, a cornerstone of both Rust and C++, arguing that its ease of resource allocation leads to sloppy resource management. He points out potential issues like decreased reliability, unpredictability in resource consumption, performance hits from scattered cleanup code, and a less organized architecture.
So instead of the usual Rust approach, they're pushing for a more controlled, static allocation model. That's a significant constraint. What's the hard mode approach here?
Hard mode means splitting the program into a std binary and a hash, no-alloc library. The binary handles OS resource requests, while the library receives a fixed-size memory slice for all its operations. Think of it as a self-contained, limited resource environment.
That's a clever way to enforce the constraints. So, the ray tracer is the example application? How does that work within these limitations?
Yep. The ray tracer's output is a pixel buffer, usually a box less than greater than. But in hard mode, they use a slice and a mut, borrowed from the main function, introducing lifetimes to manage the memory. This adds complexity, especially with nested structures and functions.
Lifetimes everywhere. I can imagine the challenges with managing those. What about parallelism? Ray tracing is highly parallelizable.
Right. Instead of Rayon, the author uses a custom thread pool design inspired by Sorbet. It broadcasts jobs to all threads, waits for completion, and uses a concurrent queue to distribute work, like slicing the image into rows for processing.
Interesting approach, avoiding the complexities of Rayon's API in this constrained environment. But how do they handle the dynamic nature of scene descriptions? Aren't those inherently variable in size?
That's a great point. They use a two-pass parsing system. The first pass counts objects, then memory is allocated, and the second pass parses the data into the allocated space. It's a clever workaround for the lack of dynamic allocation.
Smart. And what about more complex data structures like meshes? Those often involve shared vertices, right?
Yes. They use a more compact representation with separate arrays for vertices and faces, avoiding redundancy. This extends to nested structures like BVHs, bounding volume hierarchies, for performance optimization, which also require careful lifetime management.
This sounds incredibly intricate. The author mentions using a bump allocator. Is that a custom allocator?
Yes. A simple bump allocator is implemented to manage the fixed-size memory. It allocates sequentially, avoiding deallocation, and handles potential out-of-memory errors. There's also a clever use of scratch space for temporary allocations during BVH construction.
Wow, this is a really impressive feat of engineering. The author seems quite pleased with the outcome, despite the complexities. What were their main conclusions?
The author was surprised it worked as well as it did. They found that the and-mut-t pattern for owning pointers worked surprisingly well, even with nested structures. While the code is complex, the author appreciates the predictability of memory usage in this approach.
It's a fascinating exploration of the trade-offs between ease of use and explicit control over resources. Thanks for breaking this down. This hard mode Rust approach really highlights the power and flexibility of the language.
Absolutely. It's a testament to Rust's capabilities, even under extreme constraints. Thanks for joining us on Tech Bytes and News. We'll catch you next time with more exciting tech discussions. Goodbye.
Bye-bye.